You hold two magnets in your hands. Push them together, and you feel an invisible barrier, a silent force field that resists your effort. Flip one around, and snap they leap together with a startling clack, a force so immediate and visceral it feels alive. The question bubbles up, simple and childlike. Why? What is happening in that empty space between them? To ask why is to step onto a ladder that has no bottom rung. You want an answer that feels like solid ground, something built from ideas you already understand. Perhaps invisible rubber bands stretch between the magnets, pulling them together. But that's a sleight of hand. If you accept that, your very next question would be, why do rubber bands pull? And to answer that, we'd have to speak of molecules and the forces between them, which are in fact the very electromagnetic forces we're trying to explain in the first place. We'd be running in a circle, using one mystery to disguise another. That's not understanding, it's a linguistic trick. The truth is, you are already intimately familiar with the force behind magnetism. You experience it countless times a day, yet it has become so ordinary that its profound strangeness is invisible to you. Press your hand against a table. It feels solid, unyielding. You assume your skin is touching the wood, but it is not. Not really. As your hand approaches, the cloud of electrons surrounding the atoms in your skin meets the cloud of electrons around the atoms in the table. They repel each other with tremendous force. That sensation of solidity, the feeling of touch itself, is the electromagnetic force in action. It is the exact same fundamental interaction that powers the magnets in your hand. The table is no less magical than the magnet. You've simply stopped wondering about it. So why does a magnet feel so special? Because it lets you feel this universal force at a distance, unhidden by the neutral balance of everyday matter. Most of the universe's electromagnetic power is locked away, perfectly canceled. Every atom has positively charged protons and negatively charged electrons. In most materials, this charge is exquisitely balanced, positive neutralizing negative. The force is there monstrously strong, in fact, but it's hiding in plain sight. Consider its strength. The gravitational pull that holds planets in orbit is pathetically feeble compared to the electromagnetic force. The difference isn't a factor of 2 or 1,000. It's an almost unimaginably large factor. It's an absurd, incomprehensible dominance. We don't fly apart or crush together because every bit of positive charge is neatly matched by a negative charge. The universe's most powerful engine is idling silently all around us. A magnet is a place where this balance is orchestrated to create a directed, external effect. It happens in materials like iron, cobalt, or nickel. Inside every atom, electrons spin, and this spin creates a tiny magnetic field. In most substances, these spins are chaotic, pointing in every direction, their effects canceling each other out into magnetic silence. But in iron, under the right conditions, these tiny spins can line up billions upon billions of them, all pointing the same way. Imagine a stadium where everyone whispers randomly. You hear only a murmur. Now imagine everyone chants in unison. The sound carries for miles. The individual voices haven't changed, but their coordination creates a power that propagates far beyond the individual. That is ferromagnetism. The aligned spins no longer cancel. They amplify, summing into a collective field you can feel centimeters away. But this only describes the source of the field. What is the field itself? What actually transmits the push or pull across that empty space? Here, our everyday intuition completely fails, and we must descend to the most fundamental floor of reality quantum mechanics provides. At this level, the story is told not with forces like tugs or pushes, but with exchanges. The electrons in the aligned atoms of one magnet are constantly hurling tiny packets of energy and momentum at the world. These are not photons of light you can see. They are virtual photons, fleeting messengers that exist only for the duration of the interaction. An electron in one magnet emits such a virtual photon, an electron in the other magnet absorbs it. This exchange of a messenger particle is the force. The repulsion or attraction you feel is the summed effect of trillions of these unseen transactions happening every nanosecond in the space between the magnets. The breathtaking simplicity of our modern understanding is that all electromagnetic phenomena, every spark, every color, every chemical bond, every solid object, and every magnetic pull arise from just three primitive actions. A photon goes from one place to another, an electron goes from one place to another, and an electron emits or absorbs a photon. That's the entire rule book. There are no hidden gears, no secret machinery beneath this stage. The complex tapestry of our physical world is woven entirely from these three threads. Our mastery of this is not philosophical. It is mathematical and stunningly precise. In 1873, James Clerk Maxwell wove electricity and magnetism into a single, elegant tapestry of equations, revealing them as two faces of one phenomenon, electromagnetism. This understanding lit up the world. We learned that a moving electric field creates a magnetic field, and a changing magnetic field creates an electric field. This dance is why you can spin a magnet near a coil of wire and generate a current, or send a current through a wire and create a magnetic field that spins a motor. Our entire technological civilization, from the dam generating power to the light on your screen, is built on this orchestrated dance of copper and iron, guided by Maxwell's equations. Even deeper, quantum electrodynamics, the theory that describes these photon exchanges, allows us to calculate magnetic properties with almost ludicrous accuracy. We can predict the magnetic behavior of an electron so precisely that the theoretical prediction matches experimental results as closely as measuring the distance from New York to Los Angeles and being off by less than the width of a human hair. It is the most successful and accurate predictive framework in human history, and it is all about the force you feel between those two magnets. And yet, for all this predictive power, profound mysteries remain. There is a number, approximately 1 over 137, known as the fine structure constant. This number sets the strength of the electromagnetic interaction. It determines how strongly electrons are bound to nuclei, how strongly magnets attract, and the very rules of chemistry. We can measure it exquisitely, but we cannot derive it from any deeper principle. We do not know why it is 1 over 137 and not 1 over 200 or 1/10. If it were even slightly different, atoms would not hold together, chemistry would be impossible, and the universe would be sterile. The very fact that you exist to hold a magnet hinges on this enigmatic number. It is a silent, fundamental parameter of reality, written into the fabric of the cosmos for reasons we do not understand. This brings us to the final, humbling truth about understanding magnets. Our brains evolved to navigate a world of medium-sized objects moving at modest speeds. The quantum realm, where particles are also waves, where existence is probabilistic, and where forces are exchanges of virtual particles, is fundamentally alien to our evolved intuition. We possess no accurate mental picture of an electron. It is not a tiny ball, nor a wave, nor a cloud. It is what it is, and we describe its behavior with mathematics. The mathematics works with phenomenal precision, but the true picture is the math itself. We are like a supremely gifted blind calculator who can tell you exactly when and where a ball will land, but can never describe the color of the sky. So, when you feel that magnet push back, what are you feeling? You are feeling the electromagnetic force, one of the fundamental pillars of reality. You are feeling the collective alignment of countless electron spins. You are feeling the consequence of virtual photons shuttling across the void. It is the same force that gives structure to your bones, that lets your nerves fire, that makes fire hot and ice cold. Magnetism is not an oddity to be explained away by simpler things. It is one of the bedrock explanations for everything else. The magnet's magic is that it pulls back the curtain. It takes the force that operates hidden in the atomic machinery of every touch and sight and sound and makes it tangible at the scale of human hands. That push or pull is nature being disarmingly direct, showing you plainly what is always and everywhere true. We may not have a cozy, familiar analogy for it, because it is itself the foundation of all our cozy, familiar experiences. The mystery isn't in the magnet is a keyhole, and when you peer through it, you see the shimmering, mathematical, and gloriously mysterious engine of the universe humming silently in the empty space between your hands.